All right, so we are continuing our exploration of section 5.5, the substitution rule. And now we are going to work with a definite integral. As you know, a definite integral represents the area under a curve. So if we were to take this function, the x divided by the square root of 1 plus 3x, and graph that function, and then evaluate the area between that function and the x-axis, and you know, area can be positive and it can be sometimes negative, but the net area would be the value of that definite integral. So, all right, we have to ask ourselves, what substitution would we make here? So, okay, Jonathan says let u equal 1 plus 3x. I agree. So if we did that, if we let u equal 1 plus 3x, let me just hold on here. If we let u equal 1 plus 3x, in the denominator we have the square root of u. But what's left to account for would be the x and the dx. Okay, and then also, incidentally, the limits would also have to be changed, because those limits of 0 and 5 are limits with respect to the variable x. We need to find new limits with respect to the variable u. Okay, so let's go to the next page. Here we go. We let u equal 1 plus 3x. So again, this becomes then, maybe I'll put it in red, in our original integral I here, the denominator becomes the square root of u. Now, what about the, what about the x and the dx? Well, if u equals 1 plus 3x, du dx equals 3. So du equals 3 dx. Again, that just comes from multiplying through by dx on both sides here, that equation. If du is 3 dx, then dx is 1/3 du. And so this means then that dx is now 1/3 du. Okay, and that's great. That's great. We're almost there, right? But now we have to worry about this x here. Well, if u equals 1 plus 3x, then it follows that u minus 1 equals 3 times x, and so u minus 1 over 3 equals x. And so that's what we're going to replace the x with, u minus 1 over 3. Try to make that look good here. Yeah, u minus 1 over 3. And so the integral with respect to x gets transformed to this integral with respect to u. But don't forget, the limits have to get changed as well. The bottom limit, a bottom x limit was 0, right? But u is 1 plus 3 times x. So 1 plus 3 times 0 would be the corresponding u limit. And that just equals 1. Similarly, for the numerator, the top limit, I should say, the x limit was 5. Well, 1 plus 3 times 5 is 16. So you see you've got new limits here, 1 and 16. Are there any questions up to this step here? Let me know. Let me give you a moment here.
The reason why the way we reset or change the limit is by using the equation that we used to substitute u in for.
That's correct.
Okay. So if there was an equation on the top that we would use u with, we would just use that equation instead.
Yeah,
Okay.
well, whatever u equals, yes.
Okay. Thank you.
Sure. Because remember, this new integral now is an integral with respect to u. Okay, so what I'm going to do is I'm hoping this works. Yeah, Lily, or sorry, Mandy.
So under the 1, it's just like 1 plus 3 in parentheses. I can't tell what that is.
A 1 plus 3 times 0.
Oh. And then
oh, this here, that's just, ignore that there.
Okay.
Okay, so we have here, you know, this u minus 1 over 3 is the same as 1/3 times u minus 1. So the third here and the third here, I'll just bring those constants out in front of the integral. Okay, and that gets me to here. Well, Javier, I mean, it's just my style. I didn't have to do that. I didn't have to bring the thirds out in front of the integral. I didn't have to factor those out from the integral. But generally, I find constants to be distracting. So less clutter in the integral. That's right, Jonathan. So it's just my personal preference. After doing probably 1,000 of antiderivatives in my life, you know, I'm, I mean, I don't know how many I've done, but I've done a lot.
Professor?
Yes.
On the last row that we just talked about, it's 1/3 times 1/3?
It's 1/3 times 1/3, yes.
Oh, okay, okay. Thank you.
Yes, sure. 1/3 times 1/3. Well, Javier, you know, different people, their thought process. I mean, some people would just choose to leave those constants in, but it's going to make your life harder because look what happened here. What was left when we pulled the constants out? We have the u minus 1 there, the square root of u here, and the du here. And that's what we have here. But now which is pretty, you know, that's cool. But then what we have to do is we have to think, well, okay, how can I simplify u minus 1 over the square root of u? So one thing I can certainly say is u minus 1 over the square root of u can be thought of as u over the square root of u minus 1 over the square root of u. I mean, that's certainly true. And the u over the square root of u, that can be simplified, and the 1 over the square root of u can be simplified. Okay, so let me go to the next page and show you that. For everybody good here? All right, all right. So, you know, here we go, here we go. So u divided by the square root of u divided by the square root of u is equal to u over u to the half power. Right? But u is u to the first. So this is like just taking u to the first minus a half power. And that gets us u to the half power. That's how I got u to the half power here. And then 1 over the square root of u, let me just kind of separate this. 1 over the square root of u is 1 over u to the half power. Let's try to make that a little. But that's just then u to the negative half power. And that got us this here. Easy enough to get the antiderivatives of those two functions. And then you learned by the fundamental theorem of calculus how to evaluate. You know, you have to put in the 16 limit first for u, which was done here. And then you have to put in the 1 limit for u next. And that was, you know, you just substitute that in your antiderivative, and that was done there. Okay, let me give you a moment to catch up. Let me know if you have any questions. So what I do is I work this out by hand, basically. But I mean, this is something like Desmos would be very good for doing, you know, to compute this out. And now WebAssign is going to want simplified radical answers, okay? The WebAssign has, I adjusted it, it has a tight numerical tolerance. So like it's not going to normally take decimals where a fraction could be like the best exact answer. It's important that the reason I have that numerical tolerance type in WebAssign for the answers is because I don't want students to do the wrong process and then just by luck get you know, have WebAssign say their answer is correct. It's happened before. I had that happen a number of years ago. A student did their math process like wrong, but they still got an answer by luck that was close enough. But now I've adjusted the numerical tolerance, so that normally won't happen. So I mean, this is the way you want to do this kind of problem: simplified radical form. Unless WebAssign says round to the nearest hundredth or something, then it's going to want a decimal. But
Professor, for the middle section, when you plug in the limits, should there be parentheses around the individual sections?
Well,
like from the first 2/3 to the second closed parenthesis.
since I'm subtracting
Oh, okay, I see now. Okay.
these guys here. Yep. And by the way, WebAssign for like answers where you have parentheses, WebAssign is not going to want these kind of grouping symbols. It won't accept those in the answer, grouping symbols like this. If you know you're doing like an interval and it's a closed interval, WebAssign will accept this kind of notation, but not for grouping symbols. Grouping symbols, WebAssign always wants parentheses. All right, are we good here? I'll finish this up on the next page. Are there any other good questions? Okay, well then, does anybody need more time to copy this page? Incidentally, does the highlighting, like the highlighting I use with the marker, help? Is it helpful for you all? The like circling things and okay, wonderful, wonderful. Thank you, Jonathan. Good to know. Good to know. All right. All right. Well then, so my integral is going to be 1/9 times 108/3, and that's going to equal 4. So that's the answer. And we would have never gotten it without doing a substitution. That's what you know, we are finding, you know, explicit answers. On Wednesday, you're going to learn about a procedure called integration by parts. That's another procedure to help us find antiderivatives for certain integrals. But today we're focusing on substitution. How many like substitution? How many think it's kind of cool? Kind of like solving a little puzzle. How many? It can get complicated. Useful, Jonathan says, but it can get complicated. Well, and the practice you're doing in the homework is to help you so that you're comfortable with so that you get more comfortable. Are there any questions? Give me a thumbs up if you're feeling good with substitution. Okay, good. Dawit, John, Clea, Daniel, Saeed, Gabriel. Of course, Javier says he'll need more practice, and that's certainly understandable. Yep. And hold on, before you go, let me give me one moment here. Let me get that assignment activated. Could one of you just refresh your screen in WebAssign and let me know if that 5.5 assignment is okay? All right. Yeah. Is the assignment that's due Wednesday, is it visible now? Is it? Okay, excellent. Excellent. All right, I'm going to stop the recording. Very good. Great class today.